Hi guys, tonight we're going to focus on igneous rocks. It's chapter 4, section 2 in your textbook, so that's where you need to go if you want some additional information. You can also go to the internet, obviously, and do a search for igneous rocks, and you can find out more information than you could possibly want to know. So we have a picture here of a volcano that's on the left side. The reason that's there is because igneous rocks are formed from lava or magma that cools. Now, the difference between magma and lava, magma's underground, lava's above ground. That is it. That is the only difference between them. They are both melted rock. Okay, so the big question, how do igneous rocks form? Simple answer, they are formed from magma or lava that cools. Now, depending on where they're located, you're going to get some different cooling rates, which we're going to talk about in a second. So we have two categories that those igneous rocks can fall into. They can either be extrusive, which means that they're above ground, or you can have intrusive, which means they're below ground. So if you look at the diagram there, the extrusive igneous rocks are the ones that are going to be on the surface. So they're going to be exposed to the air and rain possibly, and maybe they might have lava that flows into the ocean, which is going to cool them really, really fast, and that's going to change their appearance a little bit. The intrusive igneous rocks you can see are underground. So that little pocket of gray that you see right there in that diagram, that shows you where there used to be melted rock, but for some reason it got close to the surface, it got kind of away from the main heat source, so over time it cooled pretty slowly. So, where they're located is going to affect how quickly it cools, like I said in the last slide. So the faster the magma or lava cools, the smaller the grains. Now, when I say the grains of a rock, I mean the specks. Each little speck in a rock is a piece of mineral that's crystallized, and those crystals take time to get big. So if a rock cools, once it's completely cooled, those minerals can't grow anymore. So if it cools really fast, then those mineral grains don't have time to get very big, thus the reason it's called fine-grained, which means small-grained. Okay, the opposite happens when you get those intrusive igneous rocks where they're underground. The ground layers are like blankets, so they hold in heat. Think about when you're sleeping at night. The more blankets you add, the warmer you're going to be because it holds in your body heat. So if you've got a pocket of magma that's underground and surrounded by a bunch of rock layers, those layers are like the blankets, they hold in the heat, so it's not going to allow that magma that's underground to cool as fast. So it's going to kind of insulate it, and it's going to take probably thousands of years for that to cool. Now, thousands of years is a long time for minerals to grow and get big, so what you end up with is a coarse-grained rock, which means you get a grain with very large speckles to it, which are the large mineral crystals that have had time to grow and get big. So, to sum it up for this one, extrusive igneous rocks are above ground and they cool really, really fast. That means that those mineral grains are small, which means they're fine-grained. So those three things go together. Extrusive igneous rocks, they cool fast and they're going to be fine-grained. The opposite of that, you have extrusive igneous rocks. They cool slowly, and that's going to give you a coarse-grained rock. So here's what they look like. So these are both fine-grained igneous rock. The basalt on the left, if you look at it closely with the picture, you can kind of see little tiny speckles, but they're really, really small. So it's classified as fine-grained. So that is an extrusive igneous rock that formed probably on the surface of a volcano somewhere. Now, the obsidian on the right is really, really fine-grained. It's so fine-grained that you can see a reflection off of you or the light coming off of that rock. Now, the reason it looks like that it's so shiny, is that this one, more than likely, when the lava came out of the volcano, it probably went into some kind of a water source, like the ocean, where it instantaneously cooled as it hit that water. So if it cools that fast, it's going to make those mineral grains that much smaller. So these are so fine-grained for obsidian that they're actually classified even farther as no visible grain. So here are two coarse-grained igneous rocks. Remember, they've cooled slow. They cool underground. So on the left you have granite, and on the right you have diorite. And you can see the speckles. Each of those speckles is one of those mineral grains that grew. Okay, and it took a long time for those mineral grains to crystallize and get that big. So that had to happen underground, where it cooled slowly over thousands of years. So our two main categories of igneous rock are intrusive and extrusive, and that's going to determine the grain size that you see. Okay, a couple of other things about igneous rock. You have what's called mafic or felsic, and that basically tells you the color, and it tells you how much silicon and magnesium are in there. So if it's mafic, it's dark colored. It means it contains calcium and iron and magnesium, and it's really low in silicon. So low in silicon is what gives it its dark color. The more silicon it has, the lighter it's going to be. So if you're looking at a light colored igneous rock, then that's going to be a felsic igneous rock. Okay, and that means it's really high in silicon, but it also contains aluminum, some potassium, and some sodium. So this picture kind of ties it all in. So if you look at the chart here, you have the felsic category, you have the mafic category, you have the coarse grained and the fine grained categories. So if we go along the top, if we look at granite, the overall color, the base color of that rock is kind of light colored, therefore it makes it felsic. And then you can see the speckles on it, so that makes it coarse grained. Okay, the rhyolite, which is to the right of granite, it's also light colored, so that tells you it's felsic. And this time you can't see the speckles very well, so it's fine grained. That means that one cooled very, very fast. Okay, below that, the gabbro, you have mafic. It's kind of dark in color. That one you can see the speckles pretty well, so it's coarse grained. And then you have the basalt, which we saw a picture of that a minute ago, and it's dark colored, but it's fine grained because you can't see those big mineral grains. So the last thing we're going to talk about here are different rock formations that we can get when the magma or the lava cools. So on the left we have 4 different things that we get when intrusive rocks are cooled underground. Okay, so this is areas of magma that have cooled. And then on the right we have one type of extrusive formation that you get from when lava cools. So we're going to look at these on the next page. So here's what they look like. So you can see that the dike, the stock, and the sill, and the batholiths, those are all from magma forming underground. Now you do see that the dike is listed also kind of up on the top, on the surface, but that actually used to be underground. So there were layers of rock above that have been weathered and eroded away. So it actually did form underground. So even though you see it on the ground, it was originally underground, which still makes it an intrusive formation. So you can see the volcanic neck. That's the leftover inside of a volcano after the outside has worn away and been weathered and eroded. So all that it leaves is the solid core of the volcano. And then that'll eventually wear away as well through weathering and erosion. Okay, so that's it. So make sure you bring your notes to class and get those checked off. Have a good night.